paper 1, question 10. So it just wants you to differentiate ln cos x. So part A, we're given that y equals ln cos x. So to differentiate this, we're going to use a chain rule because we've got a function of a function. We've got an ln function, and on the inside we've got cos x. So dy dx, remember the chain rule, we differentiate it as its whole thing. So to differentiate an ln function, it becomes 1 on cos x, but then we have to multiply by the derivative of the inside. Now the inside is cos x, and the derivative of cos is negative sine x. Okay, so the derivative dy dx becomes negative sine x on cos x, and that's all you need. If you wanted to, you could write negative tan x, because of course that is the same thing. Okay, part B says to find the equation of a tangent. So we've got the line, the function 2 sine x plus cos 2x, and if we want to find the tangent of course is going to look like a straight line, y equals mx plus c. That's what we're aiming for there. So m is the gradient. Now the gradient we get from differentiating. So we need to differentiate this function. Okay, when we do that, we get 2 cos x. That bit's quite easy. And then when we differentiate cos, we get negative sine 2x, but we've got to multiply by the derivative of the inside because it's a chain rule one, so we need to squeeze in a 2 there. Okay, we want it at the point x equals pi. So therefore dy dx at x equals pi. Okay, we sub pi into there and we get 2 times cos of pi. Yeah, cos of pi is negative 1, so 2 times that is negative 2. And sine of 2 pi, well, that's just 0. So it's going to be minus 0. So that's dy dx is going to be equal to minus 2. And that is the gradient, which is m in our line y equals mx plus c. Okay. At x equals pi, that says x equals pi, we need to work out the coordinate. So we know that x equals pi. What does y equal? Well, y would equal, we sub it into that original equation up here. Okay, that's 2 sine of pi. Sine of pi is 0, so that's 0. And then cos of 2 pi, that's going to be 1. So we're going to get that y equals 1. So we've got that coordinate, pi comma 1. That's going to be useful in a minute. So what we know so far is we're looking for y equals mx plus c, and so far we know that y equals minus 2x plus c. But we do know that it goes through this coordinate pi comma 1. So that's y is equal to 1 minus 2 times pi plus c. Okay. So therefore c is equal to 1 plus 2 pi. Okay, just rearranging that, and we go back to our equation, y equals mx plus c, which is minus 2x plus 1 plus 2 pi, and that is the equation of our tangent. Okay, and finally part C is asking us to find the minimum value. Okay, so that's going to be a minimum, is going to be a turning point in this case for a function. So we want to set that derivative that we differentiated over here, remember? 2 cos x, that's our derivative, that's our gradient function, and it's going to be minimum when that is equal to 0. Okay, we don't have a calculator, so we can't just let our calculator do the work. We would if this was paper 2. 2 cos x minus 2, and sine 2x, there's an identity of that, it's on your formula sheet, it's 2 sine x cos x. That equals 0. Okay, so I'm going to divide that through by 2 to just get cos x minus 2 sine x cos x equals 0. Divided the whole thing by 2, including the 0, which doesn't do anything. Now I'm going to factorise it. I'm going to have cos x brackets 1 to get the cos x, and then times by minus 2 sin x to get that second term. So I've got two things now that multiply together to get 0. So either cos x equals 0, in which case x would have to be pi on 2, or 3 pi on 2. Okay. Or the other scenario is that 1 minus 2 sin x equals 0, in which case sin x, I'd take the 1 over and divide by the minus 2, so that would equal a half. Sin x would equal a half, and just going over here slightly, x would then be, when does it equal a half? That's 30 degrees, but we're working in radians, pi on 6, or if you want to draw a quick little diagram, sine is positive here and here, so it's pi on 6 there or pi on 6 here, and over here that's really the same as 5 pi on 6. Okay, so we've got 4. So of our 4 solutions, we've got to decide which one of them is a minimum, okay, because some of them might be maximum values as well. Okay, we don't have a calculator, so we're going to have to do it the long way. Okay, so what we're going to do is we're going to find out the second derivative. We're going to go d2y dx squared. We're going to differentiate this another time. So our derivative's up there at the top right in green. We're going to differentiate it again. So when we do that, when we differentiate cos, we get minus 2 sin x. Okay, when we differentiate sine, we're going to get minus 4 sine 2x. Nope, sorry, it's not going to be sine, it's going to be cos. Cos 2x. Okay, so that's our second derivative. And we're going to say, okay, well, when x is equal to pi on 2, we're just going to sub pi on 2 into there. Okay, and we get that d2y dx squared is going to equal, when we sub it in, sine of pi on 2 is 1, so that's minus 2. So that's going to be less than 0. I'm not going to write less than 0 like that. I'm going to write is going to be negative. Now, when the second derivative is negative, that means it's a maximum, which is no good to us because we want a minimum. So we keep going. We go, well, let's look at the next one, which is 3 pi on 2. Okay, and we do d2y dx squared on that one. Okay. And we say, well, sine of 3 pi on 2 is going to be negative 1. So that's going to be positive 2 when we times it by negative 2. Negative 2 times negative 1, that's going to be 2. Okay, and then cos of 3 pi, that's going to be 0. So this is definitely going to be positive. So this one is a minimum. Okay, that's good news. Okay, that is a minimum. We'll just check the other ones quickly. When x is equal to, what's the other one? Pi on 6, d2y dx squared. Doing the same thing again, subbing in pi on 6. You should find out that that is a negative, so that is a maximum. When you sub in that it's 5 pi on 6, you should work out that the second derivative, and you can do it now by going to sine of pi on 6, 5 pi on 6, that's going to be a half, so negative 2 times a half, that's going to be 1. What is it going to be for cos? You'll work out that that is going to be negative, which means it's a maximum. Okay, so the only one that's of interest to us is this one at 3 pi on 2. we need to find out what the minimum value is, not where it is. We know that it's when x is at 3 pi on 2. So what we need to do is work out the minimum value is when x equals 3 pi on 2, and that is when y equals 2, because remember y is 2 sine of x, which is 3 pi on 2, plus cos of 2 times that, so that's going to be 6 pi on 2, or just 3 pi if you like, and we work that out. Okay, sine of 3 pi on 2, that's -1, so that's going to be -2, and cos of 3 pi, so that's going to equal -3 as our minimum value. We got there eventually.